All right, everyone, and we are back. So let's go ahead and do our question 3 on our exam. So, what material is this? Definitely some type of crystalline material, probably a metal, especially since we're told the first peak is 8, so we know this material is BCC. So this is equal to 2R, and the next value here must be 4R over square root of 3 because it's our next nearest neighbor distance. So let's go ahead and let's solve. So we're going to say 2.54. Set that, let's solve. 2.54, set it equal to 2 times r. And this is our r here. So then the other value would be 4 times r divided by square root of 3. So that would be the next value essentially here. And fantastic. So, but we do need to figure out, so 1.27, it needs to be BCC. So let's go ahead and let's find that in our periodic table. Let's not look at that. So let's go right here. Where's our 1.27? Control F, 1.27. It needs to be BCC, so that means we need this cross. So let's go ahead and look for it. Nope. It's not going to be sulfur. What do we know? Mn? Manganese? That is BCC. So that's our material. Manganese. Fantastic. Draw the RDFP of a semicrystalline polymer versus, or material. So it's going to have some plots right here. A gas is just going to be one, basically the nearest neighbor distance, the bonding distance, and then just flat here. So the long-range translational order of a semicrystalline material will be much larger than that of a gas. They both have short-range order. All right, and then last, determine the defects in the figures below. State the dimensionality. So I see something here. I'm going to go basically out of the board. I'm going to pick this as my starting location. So this is my start. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Start, finish. That's my Burgers vector. Burgers vector is perpendicular to the tangent. That's an edge. And if I go over here, I'm going to pick my tangent vector going out of the board there. So I'm going to pick my starting point actually right here. So I'm going to go 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then I need to finish up with 1, 2, 3, 4. Start, finish. So those are anti-parallel. So that is a left-hand screw. And that's it for this problem. So see you in the next one when we go to our phase diagram. Bye.